right, everybody, welcome to another product spotlight. And today we have Mercer on. Mercer Mass Timber provides timber building solutions in North America. As an integrated product to project company, they source, design, manufacture, and build. They have a new 270,000 square foot building, Mercer Mass Timber's state-of-the-art CLT manufacturing facility in Spokane Valley features one of the largest CLT presses currently in operation globally. Let's check out how sophisticated technology used at every step of the process is improving efficiency, transparency, and performance. And predictability. Todd Beyreuther is a design engineer specializing in the development of cross-laminated timber, materials, components, and assemblies, and manages product development of Mercer International's 2021 acquisition of the Katerra CLT factory in Spokane, Washington. So, with that said, we got to thank our sponsors, and then we're going to hop right into this. So, a big shout out to Forward Solutions Group and to our good friends Howick. Forward Solutions Group is successfully driving companies to succeed where others have failed. Are you looking to start a factory, optimize your existing factory, streamline your production, or take your team to the next level? Whatever your needs are, Forward has a solution for you. Reach out to Ben at forwardsolutionsgroup.com. And a big shout out to our friends at Howick. Howick Ltd. has a long history of innovation in cold form steel manufacturing and produces innovative precision roll forming technology for customers throughout the United States and the world. You want to check out their machine buyer's guide for offsite, modular construction, or fast build construction with light steel for framing. Learn more at howickltd.com. All right, how awesome is that? We can't bring you any of these informative and innovative conversations without our good friends and sponsors, so thank you once again. All right, we got a lot to cover. We got a presentation. We're talking about newcomers into the United States market and some of my favorite people. Let's bring on Todd Beyreuther. Todd, how are you, my friend?
I'm awesome. Love it. Love to hear that intro, especially when it's something passionate and close to yourself, so thank you.
Yeah, no, thank you. And I love the fact that the background, you are inside the new manufacturing facility. I'm assuming that's the big press or something behind you that does the CLT. And I know we're going to get into that. But Todd, for all those people that don't know you, we want to know everything about you from the moment you were born to this very moment in time. Do not leave out any of the good stuff from the hospital, or we will call your mother, and it'll get quite embarrassing for you. But you only got 2 minutes to do it, and then we're going to hop into Mercer.
All right, love it. Well, thank you. Yeah, my background is in structural engineering and architecture. So I grew up in northern Minnesota. I worked construction from age 12, and kind of cut my teeth in Seattle in structural engineering. And that moved into design, went to grad school in architecture at University of Washington. And then that's really the point at which then, started to get introduced to heavy timber, mass timber, and found myself at Washington State University at the Composite Materials Engineering Center, really focused on pre-market research and development of this material, of these technologies. And, that was 2011, putting together a 20-year plan for our efforts there, for my life, so forth. So we're 10 years deep into it, and I think we're on schedule or ahead of schedule, considering that we've now collectively, public-private efforts in Washington and the Pacific Northwest have really seen this industry take off. So proud to be here, and thank you for the opportunity.
Hey, listen, well, we're proud to have you here. So, let's start from the top, and then I want to get into what problem, Mercer's solving and why they saw this opportunity here in the United States. But, Katerra, right? This is the old Katerra manufacturing facility that was set up. Talk to us a little bit about Katerra and your involvement a little bit with it as well, and where this plant's going today.
Yeah, I'd love to. Because a lot of this is the introduction of Mercer. Mercer, acquired this asset out of the Katerra bankruptcy, and I think a lot of discussion about Katerra. It's that's a whole show in itself, and has been, right. But Katerra, when you look at it, it was, if you dropped 8,000 marbles into a fish bowl, you'd have 8,000 different experiences, stories. But the story of this, I take a little bit of a point of privilege because I was, mass timber hire number one with Katerra. And so really it was the question of what is it? Should we do it? And let's go develop, in the Pacific Northwest. Where would you do it? What would it look like? And then lead into what is the product development. So I think, there's an important story that this facility and that effort at Katerra was both isolated and on a really great trajectory, but also was supporting the other entities. So when we think about, the Tracy facility and so forth with our, good friend Vaughn Buckley and others and Helena, it was really interesting to see that mesh and now see this, get under really good owners, really good operators, a public company. And so, complete, obviously very different approach from venture capital money. Now we're in a very responsible operator, and that's a lot of fun. So that's really, I came back to the factory because of that.
Yeah, I mean, so you're kind of at home, right? Because you were part of helping to develop this whole thing, and I think that's great. There's just so much great innovation that came out of all that money that was spent at Katerra, and I think that's such an important thing for people to understand. There's a lot of great people out there that learned a lot of lessons working with Katerra, using some of the best equipment that's out there. So I'm really looking forward to this. So, Todd, what is the problem that Mercer saw here in the United States, or what got them to say, hey, listen, we need to start doing CLT, mass timber, in the United States?
Yeah, and maybe we should put the slides up real quick. I just had a couple intro because that's an important part. Is really those of us in the built environment, this is an introduction, and I needed it also. Who is Mercer? What are they? And as we got to know, Mercer, Mercer is a NASDAQ company. It's a public. Mercer International has 2.2 billion in revenue. It's a global company, and so when you look at all of their holdings, this is now one of them. This is their first U.S. holding, their first investment into the U.S. market, and it's also their first step towards engineered wood products. So Mercer is known in Canada and Germany for their strength in the pulp industry. They run numerous mills, as you see here. What I didn't know before getting to know them is they run the world's largest sawmill in Germany. And so we enter into this now. That's one of the most important pieces of the mass timber business, is the sourcing and the understanding of sawmilling and how we can acquire that fiber. So there was some great synergies there, and so it makes sense when you unpack it. You say, okay, I get why a company like Mercer International would like to move into this space. So.
I was going to say, I mean, the sawmill, they were in the pulp industry, you were saying.
Well, in Canada, they're primarily pulp, and in Germany, they're both pulp and sawmilling. So our European counterparts, I used to run a lab in Graz, Austria. They absolutely knew of Mercer in terms of lumber and other wood products. Yeah.
Great. So now that they're here, right, you guys are obviously operational. I mean, that's not just fun sounds in the background for no reason. You guys are operational and starting to build, yes?
Yep. This factory's been back online, and it's interesting this time around. It's not build the capacity, the physical asset. It's what do you do with the physical asset and then rebuild the right team, the right strategy to make this thing really competitive. So yes, this factory's been back online since early 2022, and we have the the privilege of bringing in some of and develop this team. We've divided where under the lead of Nick Milestone, primarily in the Vancouver, BC headquarters. That will be the project team that is servicing especially design bid build projects. And then in the Spokane part here, we'll do the focus on the operations, obviously, with our general manager, Jason Herman, and then our effort in products. So just going through the team quickly, we really emphasize both the execution, with that Vancouver team that is well known in the mass timber industry, and then also the technical side, the technical development team here with our materials and structural engineering.
Sure. Break down design, bid, build. You know, what exactly does that mean for people that maybe not that knowledgeable of CLT and what you guys do? But I think it'd be very helpful for people to understand what that means when you say that.
Yeah, I think it is relevant to start there, Dave, because this is what we're known for, right? This factory. This is Catalyst Building in Spokane. This is the first project out of this factory. They were critical path actually back in 2020. You know, can we get the factory done in time to deliver the building, right? So this is a traditional mass timber, heavy timber building, like an institutional or commercial building where that 3 to 5 stories, and now as we go up to the new codes, the 12, 18, that's competing with and mixing with steel and concrete construction. And traditionally, these projects are designed by the architects and engineers of record, and then brought to a GC to go out and bid to multiple manufacturers. So absolutely, this is still the bread and butter of this facility. But now, as we look at other models, as we get into offsite manufacturing and projects that are moving more towards design build, where we're able to be part of the team. And that's really the difference between, the VDC, the virtual design and construction, coordinating an effort versus really collaborating and finding how you really get these facilities to sing.
Yeah, for sure. So in this facility, Todd, walk us through the process and there you go, and some of the technologies that are in it.
Yeah, this is a cartoon, obviously, of one section of our press. This is a 6-foot section. There are 10 6-foot sections in this facility, so that makes a 60-foot by 12-foot, capacity. And so we think about that. We, our product that we're known for is, 3-ply CLT or 5-ply CLT. Those are often used for floors. But when you think about it from a manufacturing standpoint, we want to shove this much through every time, right? That's how we get scale. That's how we drive down costs. That's how we increase the quality. And so there's always this balance between, obviously what the market wants from an engineering standpoint and how we, really make this a competitive product. And so that's the additive piece. That's essentially 3D printing with long linear things. It's not, plastic elements. We're 3D printing on a 60-foot by 12-foot press. So that's the additive. But the fun part is when we get to the subtractive, and that's what really makes this, mass timber unique. I was trying to think the other day of another structural building product where you have this ability now to come in and take away something and do it at a millimeter tolerance, right?
So yeah, so 60 feet. I mean, so your panels coming out of there can be 60 feet long by 12 foot wide, just to be clear.
Yep, and all the way up to 12 inches deep if you want, but that's a rare application, but
sure,
you can.
Yeah. And I'm sure in this presentation, we're going to kind of walk through what the different assemblies are that you guys are working on and everything. So I'll let you go.
Yeah, I maybe put a little diagram out here I use often is we're about 2015, we were doing some federal work at Washington State University and trying to understand the what we call the techno-economics of this industry, really like the supply chain. And right now it's, we harvest a tree, sawmill cuts it into some sort of a circle to a rectangle, and then we bring it to a CLT or glulam factory, and that gets delivered on site. That's that top model that always exists, and we do that model also. And then in that research, we looked at, well, there are other models too. There are models where if you bolted this onto the side of a sawmill, that's a good model for a right-sized, smaller capacity mill, and we see our counterparts, succeeding at that. This one was really designed and was attractive in that Katera model of, well, what if we did more? What if we did more value add on the back end and really connected to that offsite manufacturing? So that's the space that we're in. That we can do all these models, but we really, want to be part of that offsite world and bring more and more of that value off, away from the site, right?
Right, for sure.
And so that looks like many things. We're making, large assemblies that really gets into not just supplying the material, but getting into, these big, 2D assemblies, rib panels, for example, like we saw in the Catalyst project, obviously big beams and so forth. But where do we go with this? Because at some point we start to now go back to that additive of how we assemble a building with these modular type strategies.
You know, you said something a few slides back, and as I'm looking at your volumetric, modules that you're putting together here, I think you're the first person that I ever heard say you're 3D printing with wood. You do realize that you said 3D printing with wood, and you really kind of are, right? And using CNC machines to give it the I guess the structure that you need outside of after you glued it together.
Sure. And I'd love to have challenges of that and get in a discussion about that, because if you think about it that way, you're taking a big round log,
Yeah.
you're doing a subtractive process to make a rectangle, and then more subtraction when we start planing it and so forth, getting it ready to be put in as laminating stock, right? All the sorting, the grading, so forth that this type of second generation facility has.
Right.
And then we're putting it back together. We're putting it back together, but in a solid format that wasn't unlike its original format. We just and then the next step is take it to the CNC machines. Let's start milling it, sawing it, cutting it, and to the design, and then we start to put it back together again. We start to put it into floor assemblies, wall assemblies, so forth. And so really it's a fun dance back and forth, right?
Yeah, for sure. All right, listen, everybody. If you're just joining us, we are live on LinkedIn, YouTube, Facebook, Twitter, and Twitch. So also get your tweets on out there. That's a hot topic these days, Twitter. Get your tweets on. Let everybody know where you're at. And if you're not following us on YouTube, man, you are missing out. We got folks like Todd Beyreuther on all the time. Learning how to build it better is what we try and teach on this show. So, Todd, appreciate having you here. And big shout out to your son, too. I think he's watching us on Twitch today. So that's exciting as well.
I agree. I always laugh at, at your comments on Twitch, but he lit up when I said, hey, I want you to sign in tomorrow.
Hey, the young people aren't coming to us, so we got to go to where the young people are. So we're having fun with it. Here we go. Back to it.
Yeah. So, where I was going with this is, in addition to the, traditional heavy post and beam structures that we think of, really the opportunity here is then what's the in-between standardized distribution of, stockable glue lams and 2x6s and so forth. And then that kind of harder approach of those big mass timber buildings. And so we're getting into this, and we're as we work with partners and help to develop their catalogs, we realize that we also need to invite them in. If we're going to say design for manufacturing and assembly, we better invite them in and help them, teach them our process so they know what to optimize and we understand their needs, their value systems. And so we've done that. And I'm showing a quick example of a prototype project. We're by no means a big pulse line in assembly. So, this is a prototyping bay. And as we work with a partner like this is Green Canopy Node. We've really valued their architectural design, a lot of our engineering design, and our understanding our process, prototyping in the back bay of this facility, and then literally piloting this. This is out back of our factory. We worked with them to build a townhouse prototype that we collectively intend to take to market. And so that's the kind of partnership that gets really exciting when really makes that bridges from just virtual design and construction to DfMA. And then the last piece I wanted to throw in here is, while we get to that additive piece that we've talked about, now let's start breaking it down again. Let's figure out where we find this cost competitiveness, and it doesn't have to always be solid wood. What would it look like if we start to look at some of the challenges we have? This is an actual Katerra picture, and I always use this. I cut my teeth in light frame buildings, so double, triple studs, and as you look at these assembly lines in these factories that are doing panelization, the pinch points are often these sub-assemblies around these windows. These, try to keep the main line on pulse. So let's get creative. Let's figure out, when we have these mass timber, this capability, is how do we go from something like this, which is a bunch of 2x4s, 108 parts, and who knows, or 24 parts, 108 nails, to 8 parts, and a bunch of these big screws like this, rather than all these fussy little hangers and so forth.
Here, put that up again. I want to show everybody.
In mass timber, this is our, language of how we, attach things, right?
Right.
These big screws, and this is one of the things we do with students, especially, is just give them a big impact driver and start driving these 12-inch, screws that, these partially threaded ones that clamp versus these all-thread ones that are really more like reinforcement. And so when you think about that, if you had that ability, especially in that light frame home builders world, and this is where we're building up towards our effort and some of our launch at IBS in a month, is let's look at that opportunity together in that framing world where we see this hybridization of not just mass timber and light frame wood, but also cold form steel. There are really good synergies between these different materials.
Yeah, no, there definitely is. And this hybrid approach is really something that we're starting to see not in Europe as well as, here. And it makes a lot of sense. I do have a question, though. When we look at the traditional paneled wall assembly versus a CLT wall system, right? The whole panel, there's got to be better shear wall. All the calculations that you would get on a building that you would need to probably have to add more metal and more bracing for traditional panelized wall. Is it less? There's got to be that cost savings there and that value engineering, because now you got a solid structure all the way across.
Yeah, I think that's the mentality. It's interesting, just speaking a little bit more of the Katerra efforts. That was, I can't, tell you how many different studies we did of, is CLT competitive to an I-joist system? Is it to a cold form steel, right? And you're always doing apples to apples of just a floor assembly or just a wall assembly. And what's really needed and what's great is when you go say, well, here on one end is the all-in solution. I don't think you should do that, but what if you made it all solid timber like those images I showed you out back? There are advantages in speed and volumetric, effort, so forth, but you really have to have the whole control of the performa. And then here's the other end. Here's the stick framing. If you have, labor on site, so forth, that obviously is going to work. But then what's it in between? And there's should be a constant spectrum in there. All of a sudden you get to the point and you say, yeah, this actually, we might do this just for acoustic rating, or we might do it because we're hanging cabinets on there. And that's the most important thing on that wall, is to have the ability to attach anywhere and have a millimeter tolerance. So,
millimeter. What does steel have? Does anybody know? Is steel a millimeter? Is there right? Really think about that. I think people have a hard time understanding that wood can be done in a way that it is engineered very, very precisely.
Yeah, no, and the answer is no. And in fact, because we're building an expansion on this factory, breaking ground in February, and it's a heavy steel frame building, clad in our CLT, and you have to be very careful on taking a material that we're milling to a millimeter and how we're detailing to something that we know could be off, 3/8 to 3/4 of an inch.
Yeah, for sure. Well, we look forward to showcasing your factory sometime down the road here when we have an opportunity. I could use some California sunshine personally, and some Washington weather's even nicer than where I'm at right now. But let's get back into your presentation here.
Yeah, so I think this is the space that we're getting excited. This has to be, through partnerships. So this is now program, sales and development with partners that need a catalog of parts. And what this means for us is now we can go make, large panels for projects, and then in all that extra material. That is one of the challenges in mass timber. It was 60 foot by 12. That sounds impressive, but what if you need 48 by 8, right? What do you do the rest of that panel, where it is a batch process, right? No one's cracked the nut on a continuous process yet. So,
right.
So as many more markets and we can find, into those sub products is really where we start to see that value proposition. So I think that's kind of the key takeaway. We can obviously talk about what that means in terms of how many of these primary facilities, we're that upper dot in the upper left there, how many of these secondary manufacturers or, can we supply, or contractors or architecture, developers, so forth, that want their own catalog. But that's really the idea when we look at how we build more and more of these facilities, because this industry is going to be supply constrained very quickly. So It's not going to be a matter of, of capacity. It's going to be, of demand. It's going to be, how do we really supply this? So.
Right, for sure.
Yeah.
Let's take a moment. I got a question here that was really from a slide ago, but it come in a little late, and let's put it up there. Steve Burrows, I'm imagining you know Mr. Steve Burrows. He says connectors are key in implementation of any wood system. So are Mercer developing connectors to more efficiently utilize fiber capacities. Is that right? Yeah, fiber capacities, the wood fiber. Got it.
Yeah, lots of ways to answer. But first of all, Steve, it's great to see you again. Yeah, absolutely, and Steve knows as well from a lot of our previous work is there's two sides to that. We're making this base material, right? This big dumb wood, and it's not dumb. I mean, obviously, the significant challenge there is how do we make now a material that is appropriate not just for this big macro where I'm going to span 20 feet, right? That's actually the easy part. The harder part is how do we make something that's appropriate for the way Steve mind works. We're developing connectors that we need control of density of specific gravity, because that's the most important factor when we're putting a bunch of dowels or screws or whatever into these high performance connectors. Right? We're not talking about 3/16 penny nails. We're saying this beam has to perform in a 2-hour fire rating on an 18-story building. We're taking something that has a natural material with a lot of variability and now trying to put high performance engineering principles around it. So I think that's one thing where we take a lot of pride. We have a unique competitive advantage in the market that this is really two factories. You're looking at the press right now. That's what we think of it as CLT and a glue lam factory. But the other end of the factory is a standalone sorting and grading line that would look like the back end of a very sophisticated mill. And that's really the key to get to the opportunity to do the innovation that Steve's talking about. So to your question, Steve, yes, but we're looking for all the partners, because that really should be the innovation that's enabled by a factory like this, not necessarily Mercer has to take the competitive advantage of the design of connectors. There are lots of people that do a really good job at that.
Love it. All right, if you're out there and you have a question for Todd, please put a Q in front of the question. And also, let us know where you're joining from. YouTube is lit up with people today. Love it. So is LinkedIn and the others. So please let us know where you're joining from, even if you just want to say hello. You might be surprised how many people reach out to you to try and do business, and it's a good thing. And that's what we're here to do, is connect everybody in this industry to grow it. All right, back to you, Todd.
Yeah, I think, just going through some eye candy here. For those of you who know my background, a lot of it's spent on, why is this factory where it is and how do we utilize our local species? And I think that is one of the challenges we have in the market is we look at our region, right? We're in Spokane and we're serving primary markets of Seattle, Portland, California, but we also can, reach way beyond that as we look at different logistics, methods, so forth. But this is really the kind of geeky technical side, but also the very exciting of how you tie into this value chain and really to deliver all these different products. And I think one thing I'd emphasize is we are now certified in glue lam. This is a big step for us now to first supply the distribution side, and that'll be a focus of our IBS, along with what we traditionally think of as our big mass timber panels. So.
Yeah, so for sure, everybody, listen, the International Builder Show 2023 is happening in Las Vegas, the last day of January and the first week of February. It is a big show. You do not want to miss it. And we're seeing a huge presence from offsite this year. Companies like Mercer and other. This is the way forward in our industry. And Mercer is one of the companies that are now leading the way with one of the most innovative factories out there for CLT. So back to you, Todd.
Yep. No, I think I'll just kind of conclude on a couple slides here. It's, I was, when we look at a big panel like this, and this is a 60-foot by 12-foot, panel, 5-ply CLT coming out of the press, right? This is what it looks like before you take it to this attractive piece. You have squeeze out of the glue and so forth, right? And then, when you let your mind kind of go with what would you make with that? I went on a great tour with the Modex, team. I think Elena was on there, Vaughn was on there, and we saw how the Japanese approach modular. Of course, we always think of how they do their big pulse lines of manual and so forth. But what's really interesting is they're buying Canadian fiber. and then they were, pressing it into glue lam and so forth, and then cutting it back up because they wanted to have control of what goes into their framing line. So, it's easy to dismiss right away. Well, yeah, that costs more than a 2x6, but when we think about those processes and how we want to use it, it gets really exciting. And it doesn't just have to be glue lam. We can make lots of headers and material out of CLT where, we want to control density for nail guns, things like that. So that's the area we're excited about. Yeah.
So this panel that you have on the screen, would this be a floor assembly or a wall assembly?
This would traditionally be a big 5-ply floor panel, and in mass timber, the mass part is really addressing the fire performance.
That's right.
That's the why. We want to take a material. So it's like starting a campfire with, a match. It's easy to start kindling. It's hard to start a log. And once it does start on fire, we know how it chars predictably. So that's really the mass part of mass timber. So this would be a great floor that you would sacrifice, 1 or 2 layers on the bottom during the fire conditions.
Sure. And let's talk about, that's a thick floor. Let's talk about the spans you can get with a floor like that.
Yeah. So it's, we think about, here's kind of the simplest thing you can do, a little 3-ply CLT, right? This happens to be screw spine fir. So when we span with something like this, we might only be able to go, 8, 12 feet or so forth, right? So this would really be, you'd want to put this on a joist system or so forth. And then when you think about that fire condition, it's going to burn through that first layer, and then you've kind of lost that integrity, right? So that's why you often have to jump to that 5-ply condition like you'd see behind me here, where you always have that longitudinal fiber in that direction. So with a 5-ply like this, between 6 or so inches, then you start to get up to 12 or 15 feet, depending on if it's a 1 hour, 2 hour fire rating. And then what's also exciting is if you can do that, you can also lay it up in a solid glue lam. So now you can start to go, I want 4 or 5 or 6 layers, whatever it might be to meet that fire condition to start to increase that span. But that sweet spot really is that 15, 20 feet, depending on fire rating.
Yeah, for sure. And what is your production capacity out of this facility, right? How much can you handle? And, I guess for people that are looking to make a switch into using more CLT or a hybrid approach to their construction projects.
Yeah, sure. So we think of like the engineered wood product industry. It's in cubic meters per year. So this facility at theoretical capacity, we advertise 140,000. Now that's hard to achieve because it's really limited by efficiency of the design. So I always put a number of 100, and that's the number that we're collectively trying to increase. The more scale we can put on this, then the more cost effective we can make this product. So a lot of it is how efficiently can we do the DfMA with our partners.
Yeah, design for manufacturer assembly, correct. Let's talk about DfMA a little bit, right? Let's say I am a contractor out there or architect or a developer, and I got an awesome project, and I want Todd Beyreuther to be my guy or the company that builds at Mercer. Tell me how the process works with Mercer, Todd. How does one get involved with what you guys do?
Yeah, it's being able to bring and rebuild a team has been exciting because we've been able to do it in a very structured way. As I mentioned before, we're building our project team led by Nick Milestone and Ricardo Breitz up in Vancouver, and that team is really the team that's going to service designs that are past CDs, right? The architects, engineers are specifying exactly what they want. This is the design, and most likely they need to go bid it against other manufacturers. And so that's the design, bid build pathway. Second pathway is going to be this more design build where we actually need to, we're invited to the table to be part of that team and early on in the project, choose this facility because this facility is unique to some other facility, and let's really see how much we can optimize. And when you do that, you can see, optimization savings of 5 to 15%, depending how. So it's really, but it's obviously a different approach, right? Yeah.
Well, it's a different approach and it's a different mathematics too. It's not, sticks to sticks as traditional builders are used to doing. You really have to look at the project from the very beginning all the way through completion to understand where the value props are. You can't compare, 1 2x4 to a CLT panel when you're trying to do the math, and I think that's a big thing.
If you don't mind me interrupting, I see a comment from Jennifer. An absolute dead on right question. Is it about cost savings or about adding value? And of course the answer is both. But what we see is mass timber is still an emerging industry. Right? Mm-hmm. We're below 5%, which by definition means we're a pre-industry, right? And what that means is we haven't really as collectively found that standardization yet. So that's really the challenge is if we're going to go a traditional approach and bid all other manufacturers against each other, we've got to go to the lowest common denominator of all those manufacturers, right? Yeah. So if that's acceptable, that's okay. But if you really want to go in and find that either a cost savings or really designed to the material, that's the added value piece.
Yeah, appreciate that, Jennifer, for putting that out there as well. Also, techno-economics. Can you define what that is for people that may not know?
Yeah, maybe that's kind of an academic way to say it. Well, what I'll say is I'll give a shout out to Washington State University, where I used to be faculty, still adjunct. Really in 2015, with the support of the Forest Service, we started looking in this region what model makes the most sense. And so the techno-economic piece of the supply chain means what are the physical things you need, what are the logistics you need, and how do those economics play out, not just within a facility, but across that entire supply chain.
Got it. Love it. Love it. All right. So, Todd, let's talk about distribution. You showed in your slide deck kind of what you're thinking. But let's talk about the region that you are serving and what are you guys projecting for growth coming up in the future? You kind of snipped it a little bit about, there's a lot of opportunity for several Mercer plants throughout the United States, possibly in the future. What's the vision look like?
Oh, I'll be very careful how I say that, right?
I won't call you on it in 5 years. Trust me.
No, I was speaking more collectively for the whole industry, right? I think when we look at, we're starting to feel these facilities across North America and Europe that we're going to be supply constrained pretty quickly. And the challenge there is, of course, the leg to bring a facility up like this is going to take now, 4 or 5 years and a tremendous amount of capital, right? So I think that's where we're starting to see those of us that pay really close attention to the market adoption and the number of projects under design and so forth are starting to see that hockey stick, that inflection point that we saw in Europe about 10, 15 years ago. Because they were the early adopters. They really drove this, and in North America we took a much more thorough code approach. We have a different we have a different code adoption, jurisdiction adoption approach. So all that being said, now we're the model. Europe looks to us as how we did it, but we're getting ready for that inflection point.
I love it. I love it. We're the model. That's awesome. So, I mean, if we look at the opportunity in the United States right now for manufacturing of offsite like CLT, there's almost like an Amazon approach needed. What does the full distribution plan look like? And is there a grand plan to have that kind of thought, behind how you can distribute and get your product throughout the United States wherever it's needed?
Yeah, by the way, that's something that I learned when I got to know Mercer. We didn't realize that was missing in the early days of this factory was that strength in logistics. I'd asked the question once, well, how do you get material, let's say, to Florida, right? Yeah. Is it by rail and so forth? Do we really have that capability? And the answer was, Mercer moves 1 million tons of material by rail in North America every year. So, well, that sounds like a big number. How many is a typical rail car? The answer is 80. I said, okay, I understand, right? That is a key point of how we can think about either it's a hub and spoke model or something more distributed, but it really we do have to think of these are capital intensive. How many of these are really should be around the resource baskets, because that's what's gonna really control.
Yeah, for sure. Who are you guys servicing currently? Who are you working with? Are you allowed to talk about any of those things?
I think there's a couple emerging that let's use IBS. Let's use this as a teaser, and then really come out of the gates at IBS. But yes, you know what? I think, you know, putting more of a kind of characteristic of projects, we're seeing obviously, you know, big commercial type projects. I think we talked a little bit about the housing space, and that's you know, to move from those big type mid-rise commercial buildings that are direct head on head with heavy steel and so forth, to move to something that is compatible with stick framing. That's obviously the biggest need in one of the bigger markets. But then I think the space that's interesting and putting pressure on everyone is the industrial buildings. There is a need to, simply from a supply standpoint, it's hard to go get roof joists right now. First, you know, it may or may not be a carbon decision. Usually it is, but we are actually seeing the ability to be able to deliver on those types of projects right now.
Sure. Well, I love it. Let's go to a couple comments. Just say hi to a few people while we're here, and then we'll come to an end and wrapped up. And I want you to think about, what didn't I cover? If there's something that you want to make sure the world knows about Mercer, who is hot off the press here in the United States and already building product, think about those things as we say just a quick shout out to a few people and say hello to everybody that's out there watching us. We got Jerry McCahey in the audience. Good morning, all, from sunny, warm Southern California. What's happening, Jerry? I left you a text message this morning. Give me a call, man. Bring me up. Good to see you, Jerry. I hope all is well. Oh, and we got Ben Hershey. Good morning, Todd. Great to see this awesome facility with Todd Beyreuther. Well, as everybody knows, Ben is Forward Solutions, one of our sponsors and salt of the earth people, man. They are the people for you if you want to start a factory, run a factory, or make your factory better. So thank you, Ben, for tuning in today. Rob Hoskin, I owe Rob a follow-up as well. There was lots of talk about mass timber, CLT, and embodied carbon reduction at the Passive House Conference in October. Cool to see the manufacturing facility. What's your thoughts on that, Todd? You know, I mean, that's true, right? Carbon reduction, all of those things are a hot topic. And, you know, there's some goals to be reached, 2030, 2050, 2040. Seems like it's a moving target for a lot of people.
Yeah, I know there's a great comment. There's so much to talk about there, but just real briefly, you know, in addition to our, you know, the private side we talked about, I'm really privileged and honored to, you know, serve in a couple public roles, you know, in local planning, but at the state level in the State Building Code Council. And in Washington, you know, we just passed our new round of energy codes, both for the commercial side and the residential side. And that passive house pathway is really important, and it is really exciting to see as you think about the need for air tightness and insulation, external insulation, what the advantages are for being able to attach something everywhere on that exterior face. And so there are a lot of synergies that will come out with mass timber.
Sure. We got a couple more questions to get through, but I do have another question that I think we should touch on that's pretty important. How about recruiting talent? Are you finding it easy to fill the jobs? Is it difficult? Do you find that all of your automation and using all the best stuff is helping you bring the young folks into the industry? How's it been for you?
Yeah, so obviously yes and no. You know, back to the techno-economics, one of the real strategies of why this thing is in an urban setting is, you know, when you look at where this, for example, should go in Washington, the answer is probably Longview, Washington, or Spokane. And love Longview, love that rural approach, but you really have to think about the scale of these facilities. And something on this scale really needs to be more in an urban setting to attract the type of technical talent, the engineers and so forth, in addition to the labor. And I think when you find, and I really learned this in Europe, not everyone in a mass timber facility has to be a millwright that has experience in a lumber mill. A lot of them are running machine centers or running, you know, modeling, digital modeling, and so forth. So I think it's important to note that this is also here because of our proximity to the technical schools, and especially to Washington State University, where we've just created an army of architects and engineers and so forth.
I'm super pumped to hear that. All right, Andrew Seeley, somewhere in Texas. All of this is wonderful. Love the timber. Good to see Andrew. And Andrew's going to be at IBS this year, so make sure you reach out to Andrew as well. Steve Burrows, man. I want to ride on that plane. Is that his own plane? Steve, is that you got your own plane, man? Mass timber tolerance and Huh? Have you been on it?
Yeah. No, what is that messaging, Steve? That you're sitting in a private plane?
I love it. Well, I know if I ever had the opportunity to ride in a private plane, it'd probably be my thumbnail as well, because
Love my pay grade.
Yeah, mass timber tolerances and concrete tolerances are very different. So how do you handle that? We saw a lot of axes in Vancouver visit to hack off bits of mass timber, axes and clown hammers, right?
Yeah, it's like you could say that's one benefit, that you can make modifications on site, but those should not be mass timber tools, right? That is not the point, and something went wrong if there's any sawdust on a site is kind of the point. Yeah, the tolerance is absolutely. And actually, one thing I'll just give a plug to Steve. One thing I really learned from him and some of the innovation when we used to work together was trying to rethink that, right? Well, why do you start with the concrete? Maybe you should start with something that has the tight tolerance and be able to shore it up, and then go, both vertical up and vertical down, right? And maybe there's answers there. We're seeing that in Europe, where we're seeing the concrete cores are actually, poured within the mass timber, as formwork. So
right,
lots of innovation needed there.
All right, appreciate you. Thank you for the question. All right, Ben Hershey has a question. Todd, thinking your expansion, can the CLT be used to replace concrete tilt-up wall construction in many of the warehouse distribution centers?
Yeah, we talked a little bit on that.
Yep.
The answer is absolutely, and really, it's as long as you. I think what's interesting is back to that. Well, what does an all mass timber solution look like? Again, that may not be and probably isn't the answer, but once you've designed it, it's easy to substitute back based on availability or cost or so forth. I think that's the big difference, is that you're taking a pretty different approach, and we're seeing surprising opportunities even in the long span roofs. I think traditionally we would have thought you only substitute out, and that's an incremental innovation. But if you just say, well, why can't I do a 48-foot span with all mass timber? What would that look like in timber composites? We're seeing the advantage there.
Great. Thank you, Ben. Appreciate you putting the question in. All right, big shout out to the UK, Scotland. Craig Campbell, how are you, my friend? Thank you for joining us today. We do appreciate you. We got George Ryman in sunny Phoenix, Arizona. George says, wondering how much modification was required after Mercer acquired the plant. Great question.
First of all, great to see you again, George. We go way back to the early days. So modification, yes. So Mercer has announced publicly that there is an expansion on the front end of the factory, and I think when you have true operators come in, they'll look at where they want to make the improvements, and the first improvements were, let's beef up an already robust front end of the grading, the sorting, and so forth. And so I think that's one thing I mentioned, that this is really two factories. That front factory is almost 2 to 2.5 times the capacity of just this press. So that is a little different than most manufacturers. That this thing is going to run full tilt boogie on making finger joint material and stockable glue lems and so forth, and then be able to pull off and divert, lamb stock into the CLT and the glue lamb press when those big projects are needed.
Yeah, George, thank you for the comment. Hey, here we go. This is somebody who knows a little something about mass timber. Hardy Wenzel, how are you? Great to see MMT enter into the mass timber space. CLT and GLT capacity is greatly needed to supply the demand in North America. I would imagine, Todd, you agree with that comment.
Yeah, no, just reinforcing that point, and Hardy knows this very well. Yep.
Yeah. Hardy has been in this industry a long time, and it was great to see him out in San Francisco as well. All right, this will be our last question of the day, all the way from France. Henry Mickelberg, slightly esoteric question, if I said that right. I know a lot of CLT factory CEOs who are not as professionally qualified as Todd. What does he think the advantage of being so brings to the equation?
I love it, Henry. So, first of all, thanks. That's nice. I maybe I don't know if I have a direct answer to that. I do, believe strongly though that This is a very technical, operation, profession and operation. And it's hard, right? We like to think we're just gluing a bunch of, 2x6 lumber together, but that's kind of like saying, to a developer who's going to put $80 million down on a building, you know what else you can buy for $80 million? A 737. And it's kind of like telling Boeing, go build me a 737, but you can only do it with material that you can buy off the shelf at Home Depot, right? This is a natural material. It's a composite material that is on the same level of complexity, if not more, of carbon fiber, so forth. So I think I am a little biased, and I hope that's reflected in the way we've built it of strong technical and business knowledge. Yeah.
Awesome. Appreciate the question and comment, and that was awfully good. I like that, Henry. Thank you. All right, let's say we got Andrew. Let me give one more shout out here, and then we're going to get back to Todd and his wrap-up comments. Andrew Wilkinson from England. Very good topic, Dave. Excellent factory operations, Todd. Thank you, Andrew, for tuning in. And then for all of you out there that are watching, make sure you subscribe to our YouTube channel. It does help us bring all of these experts to you so you can learn, and as an industry we can grow together. So hit that bell button too so you don't miss anything. But Todd, like I said back before we started the comments and question, what didn't we touch on? What do you want to make sure everybody knows about what you're doing and what Mercer's doing moving forward? The floor is yours.
Yep, I appreciate that, and let's use IBS as a launching point for these conversations, but please don't wait to reach out. What I think we're really looking for is how would you use a facility like this? When I actually left Katerra 2 years ago, I immediately contracted back to this factory. Obviously that was a problem when they went down, but the point is it was so fulfilling to me to have access to the capabilities of this facility. And that's what we're really looking for. What are you as an architect? What are you as an engineer? What are you as a student? How would you use this facility? I think it's interesting that, any architecture student, a sophomore level architecture student knows how to use a laser cutter, a CNC machine, and it's exciting. And it gets really exciting when it's a 60-foot by 12-foot panel. So let's have those kind of design innovation conversations, please.
There you go. I think the gauntlet has been laid. Let's have conversation. And let's not just do it within our industry. Let's do it with the up-and-coming students that are out there that are looking at what they're going to do in our industry to make it better. So really do appreciate that. A couple more little quick shout-outs. Kirk Hodgson, what's happening? Great discussion and presentation. So thank you for that. And let's see. Yes, thanks, Todd and others. Hi, Hardy, Annie Perkins. Annie, thank you for joining us as well today. All right, Todd, we're out of time. We went a little bit over, man, but well worth it. I really love that you landed at the Katerra plant that was built because it was one of the most state-of-the-art facilities out there, and it's in good shape. It's in good shape as I can see at the moment.
Yeah, I think that it's great to see all the familiar faces, and really look forward to moving forward.
Yeah, for sure. All right, everybody, listen, you want to make sure you tune in Friday, BS Friday, Building Science Friday with Mark Bare Naked Willie and I, 10 a.m. Pacific, 1 p.m. Eastern. This Friday is our Christmas special. That's right, we're going to be reading Cat in the Hat, so make sure you join us, or some Dr. Seuss. We're going to have fun, we're going to have some drinks, and we're going to enjoy the holiday break that is coming up. So make sure that you tune in for that this Friday, and you might actually learn some BS. Building science, as we call it on our BS Friday show. All right, Todd, don't go anywhere. You stay right there. I'll come back to you after the outro. As for everybody else out there, thank you so much for watching. If we don't see you Friday, have a wonderful holiday season. I'm Dave Cooper. Let's keep building it better. We'll see you next time. Bye now.